Now problem number 4, this one right here, it says a 150 centimeter length of wire is cut into two pieces. One of the pieces is bent to form a square with side length S. So let me draw that right away. So we have a wire of length 150 centimeters. I'm going to cut it into pieces. And with one piece, I'm going to form a square of side S. Okay, that's so far. Then let's keep on reading. And the other piece is bent to form a rectangle. There you go. With a side length that is twice its width. So basically, this side is twice this one. So if I label this as A, then this will be 2A. There you go. So far the context is pretty clear. Okay, then the question is this, or the problem is find the value of S, which minimizes the sum of the areas enclosed by the square and the rectangle. All right, that's interesting. So let's make that sum already. Let's write down the sum of this area plus this area, because that's what I want to minimize. The sum of this area plus this area. So I'm going to call that AE, area enclosed, and that's going to be the sum of these two areas. The first area is clearly S squared, and the second area is 2A squared. No need to explain that, right? All right, so far so good. This area enclosed so far at the moment is a function of two variables, S and A. And we don't know how to handle functions of two variables. So somehow I need to transform this into a function of a single variable. How do we do that? With the other piece of information that they throw at me, which is this. I know that the perimeter of this square plus the perimeter of this rectangle is equal to 150. So let me put that in here. We know that 150 is equal to the perimeter of this one, which is for S, plus the perimeter of this rectangle, which is 6A. And with this other equation, guys, that is completely independent from this one, I can make this little trick. I can isolate A. All right. I can simplify a little bit before I do anything else. We can divide both sides of the fraction over 2 in order to get 75 minus 2s over 3. Okay. Uh, even more, we can simplify a little more. 75 over 3, that's 25 minus 2/3 s. Okay, so there you go. That's A. And I can put these guys, since A is given in terms of S, I can put it back in here. So AE equals S squared plus 2A, which is all of this thing. This is a 25. Don't make that mistake. Be aware of that. Minus 2/3 of S to the square. Okay, fine. And now I have the area enclosed completely in terms of S, and therefore to us manageable. Okay, so let this be a function of S, and so it's gonna look like this: S squared plus 2 times 25 minus 2/3 S to the square. All right, and then once I have it like this, I can go on and actually solve this question, right? Find the value of S, which minimizes the sum of the areas enclosed, which is this function. So I need to minimize this function in the same way as we have done before. So let's get the derivative. F prime of s is 2s plus, make this on your own please, I'm not gonna do it for you. I'm using the chain rule in here for this part. There you go. And then we have to make this equal to 0. So it's gonna be 2s plus 4 times 25 minus 2/3, sorry, 2/3 times s minus 2/3. And you know what? Since working with s is quite complicated because you can get confused very easily with you can misunderstand an s for a 5. So I'm gonna work with x. Um, okay, I'm gonna do this. So I'm gonna have 2x plus 425 minus 2/3 of x minus 2/3 equals 0. That's much better. And now I can proceed to answer this equation. So let's do it. I'm gonna make a pause, do it on your own, and then come back. Okay, so this is the solution. Here is the whole process. You can look it up. And I get this. The solution is 300 over 17, or which is close to 17.6. You can follow the algebra. So basically, if we revert back to the S notation, well, the correct solution is this. 300 over 17, which is about 17.6. And if you do the same process as before, you will find out that this is a minimum value, right? And that should be the minimum s. Let me go to the book. Find the value of s, which minimizes the sum of the areas. So this is the value of s, which is the side of the square that minimizes the sum of these two areas. And we can see that readily if you use Desmos. This is the function, and its minimum value happens at approximately 17.6. Okay guys, so that's about it.